Welcome to another coding problem, and this is another problem in Unit 1 or prefix sums. And today we're going to be looking at the question Haybale stacks from USACO Bronze 2012, and this is considered a normal difficulty problem. So this problem is, rather than prefix sum, uses a similar idea to prefix sums, if I can say. So in this problem, we're given a list of bunch of cows, and we want to add on, or actually hay bales, sorry, and we want to add on hay bales to certain positions, I believe. And we're actually given instructions. So let's take a look at our sample test case. Our sample case is 7, 4, 5, 5, 2, 4, and 4, 6, and 3, 5. So if I have, for example, let's say this array down here, and if I'm trying to add cows from 5 to 5, notice this number is the number of cows, and this number right over here is the number of instructions, so the number of lines. So if I'm adding cow from 5 to 5, I'm having one more cow here. From 2 to 4, I increase everything here. From 4 to 6, that would be 2 to 1. And from 3 to 5, that would be 2, 3, 3. Like that. But notice, here's what I can do with this problem. If I manually simulate all of the adding on and if I simulate all of the instructions, so I increase cows from certain intervals, that's going to take lots of time. So that's not quite a good that's not good enough for our time complexity. So what we can do is we can use a method called critical points, which we'll also take a look at in Unit 2. Critical points. But it's kind of similar to prefix sums in a way, which you'll see later. Instead of marking where Farmer John stacks his hay bale, what I'm going to do is I'm going to mark where he starts and where he ends. Let's take a look at what I mean. So here, I'm trying to add a hay bale from 5 to 5. So I'm going to start adding a hay bale at position 5, but I'm going to end adding it at position 6. Notice how I added one here. So I start at number 2 if I'm looking at this one. So I start at position 2, and then I end at position 5. For 4 to 6, I start at position 4, and then I'm going to end at position 7. So I'm going to end right here. And from 3 to 5, I'm going to start at position 3, and then I'm going to end at position 6. Notice, let's say that I have a counter, or how many hay bales I'm adding. So num hay bales, for example. Num hay bales. In the beginning, this is going to be equal to 0 because I'm not adding any hay bales. What I'm going to do is I'm going to linearly search through this array in O of n time. Notice that marking all of these points on my array was O of k time for k instructions. And I'm going to be linearly scanning through each and every element of my new critical points array. So what I'm going to do is I'm going to look at how many start points I have and how many end points I have. So let's take a look. At index 2 or at position 2, I'm going to add one hay bale. So I am going to add, so there's going to be one hay bale here, and num hay is going to be 1. And at 3, I'm going to add another hay bale. So num hay bales is going to increase to 2. So at position 3, I'm going to have 2 hay bales. And at position 4, I'm going to add one more. So I'm going to have 3 hay bales here. So num hay bales is going to be 3, and I'm going to mark that at position 4. But look at what happens in position 5. I add a hay bale, and at the same time, I remove a hay bale. So in total, I'm not adding another hay bale. So position 5 is going to be 3. But notice what happens at position 6. I remove 2 hay bales. So I'm going to subtract 2 from number of hay bales. So I'm going to get 1. So 1 here. And at position 7, I remove it once again. So I get 0. So 1 minus 1, which is 0. So notice I have constructed my hay bales array in O of n time. So I processed all of my instructions in O of k time. So I have to add the two numbers together to get a total of O of n plus k time complexity. And at the end, our question wants us to find the median height. So I'm going to put a 0 here as well. So notice all of my hay bales are going to be 0, 0, 1, 2, 3, 3. So I'm going to order them 0, 0, 1, 1, 2, 3, 3. And I take a look at the median, so the middle element. And therefore the median is going to be 1. So that was it for this question. I hope that you had a lot of fun, and I'll see you in the next one.